Read Chapter 4 on reference points. It goes over moving horizontal lines, vertical lines, foreshortened lines, backward and forward in space using these reference points. There are a few mistakes that are common when using reference points. One thing to keep in mind is that reference points will only move parallel lines backward and forward in space. And the lines that are being moved, they have to be on the same horizontal plane. For instance, if I put a horizon line here, and I'm going to make a vertical line, just at a random length, and let's say it sits on the ground right there. Now, if I wanted to just move it backward in space, and I didn't really care where it was necessarily, I can just make up a dot. Any dot can be a reference point. So when I draw a line from here to here, these two lines are parallel with each other. This line is directly above this one. So any line that I draw that is vertical, that is parallel to this one, will make this the same length as this. I can put it back here or over here. But what I can't do is draw another vertical line. Let's make this one in a really particular place. Here it's here, and I want to move it there. In this case, the reference point can only be in one position. I can connect these two, and it can only be there, this reference point, if I'm moving this to here. But I cannot do this. You will see how obvious it is that this is wrong. But see, this one and this one, they're not parallel with each other. So this is going to become obviously way too long, way much longer than this one. So the lines that you draw, you have to make sure that you're using the same point to make sure the lines are parallel with each other. Horizon line, and let's do a horizontal line. Here's a random length of a horizontal line, and I want to move it, let's say I move it right there. I want this to be there. And the only place that a reference point will work is right there. So any line I draw that's horizontal, it's parallel to the horizon line. Between these two red lines, any line I draw anywhere, they are all going to be the same length. I can even come out in front like that. So what's happening with this, if you imagine this like as a plan view, you're looking straight down on this scene. If you're looking straight down on this, these two red lines are going parallel with each other. So you could see that any line I draw between these two red lines that are parallel, they're going to be the same length. Now, if I drew a line like this would not be the same length as the others because it's not parallel. It's equivalent of me doing this. See this brown line here that I just drew, it's much longer than this one. So this one is the longest one of all of these. But all the others are all the same size. So we know not to use different points, which is hopefully kind of obvious, but when you get a drawing going and you will see lots of points along your diagram, it's really quite easy to mix them up, especially like if they're close together. You might have like a vanishing point or a measuring point right there, and you take this and you bring it to here, and then you go do something else, and then you come over here and you go to the wrong spot like that. Then it can look like they are pretty darn close to being correct, but this is not right because they need to go to the same dot. The other thing is that the lines have to be on the same plane in space. So I'm going to draw a little box. Here's a 1-point perspective box. And here is a length, vertical line. It sits on the ground right there. And if I wanted to put it in the middle of this box, well, an easy way to find the middle of this box is just to put an X through it. So I want to take this and set it on top of that box. I want this to be there. So if I did this and found a reference point, see, this would not be correct. You can't do this. You can't take something on the ground and move it to a different spot vertically with a reference point. The reference point draws lines that are parallel to the ground. If I drew a line from here to there, it would not be parallel to the ground. It's going at an incline. You would have to use a different type of a point that is not on the horizon line to do what I'm doing here. So there's workarounds for everything. See, this is actually going along the floor and hitting the box right there. From this point on, it's going underneath the box. It's never really hitting this spot. This is on top of the box. They're just kind of visually lining up with each other. This one is staying along the floor, and this one is above the floor. So here's how to approach this one. Another 1-point perspective box. We can tell it's 1-point perspective because the vertical lines are straight up and down and the horizontal lines are parallel to the horizon line. So this makes that dot the center of vision, your 1-point vanishing point. Now I want to take this, it's sitting on the ground right there, and I want to move it to the top of this box. It needs to be a 2-step process. So I'm going to move it over to the middle of the box, then I'm going to raise it up. Here's the center of the box. This is on the ground, and this is on the ground. So I can go from this dot to the center of the box and extend this out, and I get a reference point. And then take the top back to the same dot. So this is the line moved to the middle of the box on the floor. So when you move things up and down or side to side, they don't get bigger or smaller. It's only when they go backward and forward in space. So for instance, if I wanted this to just move over to the left or right, this is easy. I don't need a reference point for that. There. Now they're the same size. I mean, you could just take a ruler and use a ruler to do that, which is what I'm going to do here. I want to take this. It's right in the middle. I want to move it up to the top of the box. So I'm going to do another X to give me the middle of the box right above this line. So I can just take a ruler, measure this, and bring that up. Now this line is the same size as this one. And you can see if I try to do it this other way, going from here to here, and use a reference point and then do that, you can see I'm getting a different result. If you try two different ways and you get a different result each way, then something's wrong. So these reference points are kind of like vanishing points, but there's a little bit of a difference to them. Like this stick, if you can just imagine this having one dimension, it has no real vanishing point. It's just a vertical line. If it was a one-dimensional line. This box, this is the vanishing point for the box. If the box was long enough, it would disappear right there. The vanishing point is where the object disappears if it goes back far enough in space. A reference point is just a tool that you use to move lines back and forth in space. One more example. That's a little more complicated than just moving a line around. Let's make vanishing point there. I think to keep this simple, I'm just going to do a rectangular shape. And let's say I wanted this. I want another shape exactly like this one, but I want it to be here. I want this to be moved to here. So I can take these two, connect them, and create a reference point. This is the vanishing point for this rectangle. This is a reference point because it is just a tool that I use to take this dot and move it here. So straight across from this dot is going to be the width of this box. And I want it to be the same width as that one. So I go back to this reference point. Now this line and this line are the same length. This is parallel to this one. These two have to be parallel. So the lines that are going back in space, they have to go to the same vanishing point. And I want this length to be the same as this length. Just switch colors. And I want to move this dot to here. I'm going to use the same reference point because all these lines need to be parallel. So there. Now, this line that's going to this vanishing point, is the same length as this one because they're parallel with each other. Any lines that go to the same dot are parallel. Now these two are the same size. I don't know what size they are because I didn't make a scale. I could do the same thing with height if I wanted to add some height to it. And let's just make a random height. Let's try that. And we'll close this off and we'll make this a three-dimensional box. Okay, I want this one to be the same height as this one. So I'm going to be using this same reference point. I got that spot from this one, and here's a vertical line. And if I take this vertical height and bring it across here, and make sure these are parallel. So now this is parallel with this one. And then it's just connecting dots. Now I have two rectangular prisms. They're exactly the same size. This is the vanishing point. This was just a tool I used to move this to here.